Part C. As electrons pass through the tube, they are accelerated by an electric field produced by a 5000 DC potential difference. The night vision device is powered by a 3 volts DC supply. The production of the 5000 DC supply is not straightforward. There are 3 steps. First of all, you have to get from step 1 3 volts DC to 3 volts AC. Step 2 is 3 volts AC to 5000 volts AC. And step 3 is 5000 volts AC to 5000 volts DC. Name the device used in step 2. So from 3 volts AC up to 5000 volts AC, you're going to use a step-up transformer. Why is it necessary to convert DC to AC in step 1? And the problem is that you need, if you want to increase the size of your 3 volts there, a transformer only works with alternating current. So a transformer only works, or can only be used with AC. And the reason is because you need a changing magnetic field. In fact, it was a changing magnetic field bit which was actually in the mark scheme, so that's what you should explain there. Give specific detail about how 3 volts AC is converted to 5000 volts AC in step 2. And so what you have is you have got a primary transformer with less coils and a secondary transformer with a lot more coils. So the number of coils in the primary, number of coils in the secondary. So the ratio of the number of coils in the primary over the number of coils in the secondary is equal to 3 over 5000. And you need to, it's really the ratio idea that they're looking for there. Calculate the velocity gained by an electron when it is accelerated from rest through a potential difference of 5 kilovolts. So if it's accelerated due to a voltage, then the energy it gets from that voltage is E is equal to QV. And Q, of course, is the charge on an electron. So EV, if E is the electronic charge Q, is equal to half the mass of an electron times its velocity squared. Then V squared is equal to 2 EV over M, which is 2 by 1.6 by 10 to the minus 19, times V is 5 by 10 to the 3, 5 kilovolts. And then it's divided by 9.11 by 10 to the minus 31, which is the mass of an electron. And that answer comes out as 4.2 by 10 to the 7. And that's the answer. Part D. It is important that electrons travel in straight lines in the image intensifier tube so that when the electrons hit the fluorescent screen, the same image is created on the screen. The cathode ray oscilloscope uses the same principle. Here electrons also hit a fluorescent tube to create a spot of light. Describe briefly how in a cathode ray oscilloscope this single spot of light is moved vertically up the screen to a new position. Use a diagram to explain your answer. So what you have are 2 plates. And those 2 plates are Y plates. If you want your spot, which is an electron, now an electron has a mass, an electron is going to go like that as it moves along. It's going to move in a straight line and then be influenced by gravity. But you want a positive plate up here to attract it upwards and a negative plate to repel it upwards. And so you have got voltage on the plates, on the Y plates. So you can apply an electric field with a positive charge on the top plate, and therefore the electrons experience an upward force. The movement of the spot of light in D part 1 is the basis of the measurement technique. State the quantity that is being measured. So it's on a CRO, and that scale, the Y scale, is going to be a voltage. So it's a DC potential. or a voltage. State how the vertical movement of the single light spot could be changed so as to produce a continuous vertical line. In other words, a line that's going up and down like that. And that all you have to do is apply an alternating current or an AC signal across your Y plates. And that will produce a vertical line.